This whole chapter is on factoring. Remember, like at the beginning, I told you we're going to learn a lot of different types of factoring, a lot of different methods of factoring. And this is not something that you can learn one method and just kind of ignore the others and you pick one. This is something where you have to know all the different methods because certain problems are just going to require certain methods. Right now we have two. We have factoring by GCF. And we have factor by grouping. These are two that we have to know how to do. Factor by GCF would be something like if you have 3x squared y to the fourth minus 6xy to the fifth. You say, what do those two have in common? We can both divide by 3. They both also have an x. They both also have at least 4 y's. And then you divide. Well, you divide this by that, and all you have left is a single x. You divide that second one by this, and you have minus 2. The x is gone. We'd still have a y. And basically, it's like undistributing, right? The weird part, the only difference between this and distributing is we don't know what was distributed, right? So we have to come up with what number kind of got distributed, and then we undistribute it. Make sense? And then we have the factor by grouping, which was a problem like this one, where we didn't know what was, you can't divide all these terms, so there is no GCF that we can pull out. So we said, all right, these have a t squared, so we can pull out a t squared and get that t minus 5. This one we pulled out a negative 2 to make negative 5 and a positive t. Now these both have a t minus 5, and then we can pull out to those. So now we have factor by grouping. Those two methods we have to know. But then there's going to be a third method. Okay, what we're talking about today is I call the easy type. Okay? It's not a formal name, it's just what I call them. And those are going to be problems in this form. Okay? X squared plus bx plus c, where this is always going to be a 1. So an example would be x squared plus 4x plus 3. The b can be any number and the c can be any number. These problems are what we're working on today. Okay? Before we work on factoring, I want to do a quick review. Let's say I gave you this problem and said FOIL it. What would I get? X times x is x squared. X times the 2 would be 2x. The negative 7 times the x is negative 7x. And then the negative 7 times the 2, negative 14. Now, when I combine like terms, I'm going to get x squared minus 5x minus 14, right? That's what that FOILs into. What we're doing today is we're going to flip this. And our goal is to go from here back up to there. So the question's going to be, how do we get that middle term, and how do we get this last term? So, let's start with the 14. Where did the 14 come from? Well, where did the negative 14 come from? It came from the negative 7 times the 2, right? So when I want to factor a problem like this, I know it's going to factor into something that looks like that. And then let's start with this. Where did the x squared come from? Where did the x squared come from? The x and the x, right? It came from x times x. Well, the same thing is going to be true. What do you think, what two things are going to multiply together to get x squared? X and x, right? The problems we're doing today are always going to start with that. They're all going to have x and x, okay? And then the question is, where's the 3 going to come from? Where's the 4 going to come from? Well, in a problem like this, we've got to think, where did the negative 14 come from? The negative 14 came from the negative 7 times the positive 2, right? That's where it came from. And where did the negative 5 come from? It came from the negative 7 plus the 2, right? So that's where those things came from. So factoring boils down to a bunch of questions where we've got to figure out two numbers. Two numbers that will multiply together to get a certain number, and those same two numbers have to add up to be a different number. We're looking here for two numbers that multiply to 3, and at the same time add up to 4. What are two numbers that multiply to 3? 3 and 1. Do those two numbers also add up to 4? Then the answer is going to be that. X plus 3, x plus 1. Now, when problems are plus and plus like this, where these two signs are positives, it actually is a fairly simple process. Because let's say we take a problem like x squared plus 7x plus 12. Okay? What two things multiply to x squared? Well, I know it's going to be x and x. Okay? But what are we looking for? We're looking for two numbers that multiply together to equal 12 and add up to 7. 3 and 4. How did you come up with that 3 and 4? But my question is for the other people in the room that didn't, like you came up with it like that. Other people in the room are going, all right, where did she get that 3 and 4 from? Factoring really is guessing and checking. It really is. What it's going to come down to is solve this problem first. What are some different ways to get to a 12? 1 times 12, 2 times 6, and 3 times 4, right? Like that's what you're doing in your head. You're saying, what are all the different ways to get to a 12? Then you're also saying, out of that list, which of those also add up to 7? Right? Like that's kind of what you did in your head. So now we're saying the answer is x plus 3, x plus 4. And that is the correct answer. Yeah, so now we got to start talking about what happens when we start changing these signs. A problem like this versus a problem like this. There's almost no difference. Because this is going to be x, this is going to be x. That part's easy. And again, we're looking for two numbers that multiply to 12. And now we're looking for two numbers that add up to a negative 7. Well, how do you multiply together to get a 12? How do you multiply together to get a positive number? Two positives or two negatives. So if this is a positive, so we're going to have some rules. Okay? If you see x squared plus bx plus c, that means you're going to have two positives. Because how do you multiply together to get a positive? Well, either two positives or two negatives. If this is a positive, that means you either have to have two positives or what's another way to get two positives or get a positive is two negatives. So if you see this sign is a positive, that means you know your signs have to be the same. Either two positives or two negatives. If this is a positive, that means they're the same. They're both positive. If this is a positive and this is a negative, that just means you're going to have what? Two negatives. Does that make sense? So, this problem, you're looking for two numbers that multiply to get a 12 and add up to a negative 7. What are two numbers that multiply to 12 and add up to a negative 7? How about negative 3 and negative 4? Negative times a negative is still a positive, right? And a negative 3 plus a negative 4 would be a negative 7. So this just means it's going to be negative 3 and negative 4. Does that make sense? If this is a positive, this problem's fairly easy. And I like to actually think of these in reverse. The way when I factor, I read them from back to front. I say, all right, I'm looking for two numbers that multiply to 12 and add up to 7. Well, that'd be 3 and 4. If this is a negative, I know my two signs have to be negative. Let's try another one. Let's say I gave you x squared minus 9x plus 18. What am I looking for? I'm looking for two numbers that do what? Multiply together to get a positive 18 and add up to a negative 9. What are some different numbers that multiply to 18? 3 and 6, right? That would work. Now, 3 and 6 do multiply to 18. But 3 and 6 don't add up to 9. They add up to positive 9. I would want negative 3 and negative 6, right? So it would just be negative 3, negative 6, and it makes absolutely no difference whether you write x minus 3, x minus 6, or you write x minus 6, x minus 4. Those two things would be exactly the same. It makes no difference which one you put first. Okay? Now, the slightly more difficult problems, guys, please heads up. This right here is probably one of the most important things we've done all year. It really is. This is something you have to know moving forward. Now let's say we take a problem like x squared plus 2x minus 15. The fact that this is a negative means I'm looking for two numbers that multiply together to equal a negative 15. What does that mean? How do you multiply together to get a negative? You need one positive and one negative, right? So basically, if you see, it doesn't matter whether the b is positive or negative right now. No matter what, you're going to have one positive and one negative. Because how do you multiply to get a negative? The only way to multiply is to get to negative is to have one positive, one negative, right? Because if you have two of each, if they're the same, you're going to end up positive. So the question then becomes, which one is positive, which one is negative? That will matter. Oops, I went the wrong way. So, we're working on this one here. We're looking for two numbers that multiply together to get negative 15. And those same two numbers still have to add up to be a positive 2. So 3 and 5 multiply to 15, right? The question is going to be, which one allows us to say this is correct? Negative 3 and a positive 5. Right? Because basically, one has to be positive, one has to be negative to end up to being multiplied to negative. But they have to add up to a positive. How did you know it was going to be the 5 was going to be positive? So the bigger number basically has to end up being the positive. So, when you do this, if this is a negative, our signs have to be different. If this is a positive, which number is going to end up being the positive number? The bigger number is going to end up being the positive number. If this is a negative and this is a negative, this negative means my signs have to be different. What does this negative mean? The bigger number is just going to have to be the negative value. So that same problem, let's say I gave you instead x squared minus 2x minus 15. Oh, I never finished this problem, did I? So it would be x plus 2, or no, plus 5, and x minus 3. That's the answer to that problem. This one, I'm still looking for two numbers that multiply to 15, and they have to add up to be or multiply to a negative 15, and now they have to add up to a negative 2. Here's how I like to think of these. I'm looking for two numbers that multiply to 15 and subtract to 2. What are two numbers that multiply to 15 and subtract to 2? 3 and 5. This sign means my signs have to be different. This tells me the bigger one has to be the negative. Does that make sense? What if I gave you a problem like x squared, how about negative 5x minus 24? What am I looking for here? I'm looking for two numbers that multiply to 24. And the way I would think of these, subtract. This side always tells me, do I add or subtract to the middle number? I'm looking for two numbers that subtract to 5. What are two numbers that multiply to 24 and subtract to 5? 8 and 3. So, I know my answer is x and x, 8 and 3. This sign here, what does that sign there tell me about my two signs? They have to be different. That means one of them has to be positive, one of them has to be negative. Which one's positive, which one's negative? This sign tells me the bigger sign has to be, the bigger number has to be negative, which means the 8 has to be the negative and the 3 is the positive. How could you check these to make sure without a shadow of a doubt that this is the correct answer? FOIL it. Just FOIL it. What's x times x? X squared. What's x times 3? 3x. Positive 3x, right? What's negative 8 times x? Negative 8x. What's negative 8 times positive 3? Does this simplify back to this? Absolutely. The signs are the hard part of these. I don't think these are difficult problems. I really, really, really don't. Because, I mean, I prove it to you by, I call these the easy type. What am I looking for here? Two numbers that do what? Two numbers that multiply to 24 and add up to 11. What are two numbers that multiply to 24 and add up to 11? When in doubt, just start listing your multiples of 24. What are some different ways to get to 24? 1 times 24, 2 and 12, 3 and 8, 4 and 6, right? Those are all different ways to get to a 24. Which of those also add up to 11? 3 and 8. This sign, what does this sign being a positive mean? It means I have to have the same signs, right? This sign then tells me they are both positives. How would the answer change if I change the problem to x squared minus 11x plus 24? I'm still looking for two numbers that multiply to 24 and add up to 11, so it's still 8 and 3, right? This sign tells me my signs have to be the same. They just have to be both. That's an 8. So the only thing that changes if this is a negative is they're both negative. Does that make sense? Are we okay with these? Everybody take out a sheet of paper. Everybody take out a sheet of paper. Factor that. Go. X squared minus 12x plus 32. We know that's going to be part of our answer. Walk me through, what are we looking for? I'm looking for two numbers that do what? Multiply together to equal 32. I'm also looking for two numbers that add up to 12. What are two numbers that multiply to 32 and those same two numbers add up to 12? 8 and 4? So far so good? So I know 8 and 4. Now I got to worry about my signs. What does this sign being a positive 32 mean? That means they have to be the same. They're either both positive or both negative. This means they have to be both negative. Yes? What do you mean? Yeah, so if this is a positive, that means both of our signs have to be the same. And they have to both be negative. Let's try another one. I'm going to try this one. X squared minus 12x minus 32. What are we looking for here? It's different. How is this one different than the last one? The 32 is negative now, right? So what am I looking for? What does this sign being a negative mean? How do you multiply together and get a negative? How do you multiply together to get a negative? How do you multiply two numbers and the answer is negative? You have to have a positive and a negative. The fact that that's a negative tells me they have to be different. Now, what am I looking for here? Two numbers that do what? Multiply to 32. So what are some numbers that multiply to 32? Well, it could be 1 times 32. Could be 2 and 16. 4 goes in there. 4 and 8. 6 go in there? No. 7? No. That's it, isn't it? I'm also looking for, on that set, two numbers that subtract to get 12. Are any of these numbers going to subtract to 12? Well, how did I know they have to subtract to 12? How do I know they have to subtract to 12? One has to be positive, one has to be negative. I have a negative 8 and a positive 4, or I have a positive 8 and a negative 4, aren't I really going to subtract the 8 and 4 in my head? Yeah. Now, are all problems going to factor nicely? No. This is the problem with all factoring, is not every problem can be factored every single way. Can this problem right here that I just wrote on the board, is there a nice answer to this? Are there two numbers that multiply to 32, two nice numbers that multiply to 32 and subtract to 12? No. So not all of these problems are going to have nice answers. Some of them we may need a different factoring method, and that's why we have to have multiple methods of factoring. So this one I would just say, can't factor right now. How about trying to come up with some good problems here. How about that one? What do I know about my signs? Let's talk about our signs first. We got x and x. What does this sign mean? They're both the same, and they're both going to be negative. What am I looking for here? Two numbers that multiply to 24. I always read them this way. I'm looking for two numbers that multiply to 24. This sign right here will tell me I'm adding or subtracting. I have to add up to 10. What are two numbers that multiply to 24 and add up to 10? 6 and a 4. Done. Because my signs have to be the same, and they're both negative. Now, how would this problem change if I did this? Now, what am I looking for? Two numbers that multiply to 24 and subtract to 10. What are two numbers that multiply to 24 and subtract to 10? 12 and 2. So now it's two totally different numbers. This sign tells me my signs have to be different. The bigger one is now, so the 12 is negative, the 2 is positive. So by changing just that one little sign, totally changed this problem. It totally changed the numbers as well. So, when you do these, you have to understand your signs. If you have two positives, positive and positive, you'll always have two positives. This sign tells me they're the same, they're both positive. This sign tells me they're the same, now they're both negatives. If this is a negative, if the C is negative, that means my signs have to be different. So no matter what, I'm going to have one positive and one negative. But then the B tells me the bigger number has to be the same as that one. So if this is positive, the bigger number is positive. That's negative, the bigger one's negative. Does that make sense? I don't think these should be hard. I really, really don't. When in doubt, write out the numbers. Let's say I gave you x squared plus x minus 72. Oh, 72 is a big number. When in doubt, start writing out the numbers that multiply to 72. 1 times 72. 2 and 36. What'd you say? 8 and 9. Yeah, 3 will go in there, 6 will go in there. There's a bunch more. But which of those also subtract to 1? 8 and 9. So if you can come up with your numbers, two numbers that multiply to 72 and subtract to 1, 8 and 9. My signs have to be different. The bigger one is the positive. You're done. How are we feeling with this? Pretty easy? We have 3 methods of factoring so far. Pulling out the GCF, factor by grouping, and now I call them the easy type, where it's just this number is always a 1. It's just x squared here. And then the b and the c can be any numbers we want. Okay? Everybody take a look at page 544. 544. Let's try the first problem of your homework together. So it's x squared plus 14 plus 40. This is number 3. What am I looking for here? Two numbers that do what? Two numbers that multiply to 40 and add to 14. What are two numbers that multiply to 40 and add up to 14? 4 and 10. This tells me my signs have to be the same, both positive. There's your answer, x plus 4, x plus 10. And again, I don't care. It doesn't matter if you write x plus 4, x plus 10, or if you write x plus 10, x plus 4. That makes absolutely no difference as long as they're the same. Are we good? Let's try number 6. What's number 6 say? X squared plus 15x plus 44. What am I looking for? Two numbers that do what? Two numbers that multiply to 44, add up to 15, which are 11 and 4. My signs have to be the same, both positive. And there you go. Let's try number 9. X squared minus 11x plus 24. What am I looking for? Two numbers that multiply to 24 and what? No, they're still going to add up to 11. This sign tells me they're going to add or subtract to that middle number. So I'm still looking for two numbers that multiply to 24 and add up to 11, which are 8 and 3. This sign tells me my signs have to be the same, and now they are. So what are my two signs? Negative, negative. Make sense? All right, keep going. How about number 12? X squared plus x minus 30. What am I looking for? Two numbers that multiply to 30 and subtract to 1. What are two numbers that multiply to 30 and subtract to 1? Five and 6. This sign tells me my signs have to be different. Bigger one has to be positive, so the 6 is the positive, the 5 is the negative. If I would have put the 6 first and the 5 first, my signs still have to be different. My bigger number still has to be the positive, so the 6 has to be the positive one, and the 5 has to be the negative. Either one of these two answers is acceptable. But the 6 has to be the positive and the 5 has to be the negative. You can't flip-flop your signs. How about 15? Let's do that one. X squared minus 4x minus 45. All right. Every third to 48. Go.